Let us look at this particular question. The question reads, the graphs of the function of x is equal to a sine x and g of x rather is equal to cos x plus 1 for x an element of 0 degrees to 360 degrees. So if we are to write down what this statement is saying, we have two functions. We have the function of x, which is equal to a sine x. We also have g of x, which is equal to cos x plus 1. Then we are told that in both circumstances, x is an element of the closed interval 0 to 360 degrees. Then when we look at that graph, we can see that we have, for x, we are going to have 0, 90, 180, 270 and 360 degrees as stipulated by the question. But for y, we are starting from -1 up to 2. Let us quickly answer 6.1. So in order for us to answer 6.1, which is asking write down the value of a, how are we going to determine the value of a? We are going to use the information or the knowledge we already possess, or the knowledge we are suspected to be possessing of special angles. So we should already know that sine of 90 degrees is equal to 1. That we should know. So since we know that sine of 90 degrees is equal to 1, when we incorporate the function of x is equal to a sine x, let me write it down. The function of x is equal to a sine x. What it simply means is we have to substitute this x with 90 degrees. So it becomes the function of 90 degrees is equal to a sine of 90 degrees. But since we know that sine of 90 degrees is equal to 1, this means the function of 90 degrees is going to be equal to a times 1, which simplifies to the function of 90 degrees is equal to a, like that. But we can now still come to this graph. Then we look for 90 degrees because we want to determine what the function of 90 is going to be. We have manipulated this from the premise or from our knowing that sine 90 degrees is equal to 1. Now we have come to the realization that the function of 90 degrees is equal to a. When we come to our graph, we look for 90 degrees, we find it here. Then we follow it until we reach f of x, which is this. Then when we seek out what is going to be the value of the function of x or y when x is 90 degrees, we find out that it is 1. So the function of 90 degrees is equal to 1. From this realization, using the simple laws of transitivity, we can deduce that therefore a should be 1. Since the function of 90 degrees is equal to a and the function of 90 degrees is also equal to 1, so a should be 1. If you have any questions, please don't hesitate to ask. So this is how we do 6.1. Let us move on to 6.2. Now when it comes to 6.2, it wants us to determine the range of G. So there's something we should know beforehand. We should know that range is closely associated with y, that is the output. If you remember when we learned about functions, we said we have the input, which we can call the domain, which contains elements which are mapped to the output, which can also be called the codomain or the range. So we have a mapping, and this mapping is the function. So that is what we learned, right? When it comes to understanding the range and the input. So since we know that, let us clear out this part. Since we know that the range is associated with y, which is the output, and we are tasked by 6.2 to find the range of g, we are going to be looking at the relationship between the function g and the y-axis. And if you look closely, you are going to see that the minimum point occupied by this function g relative to the y-axis is this point, which is actually a 0. Then it is going to rise to this point, which is actually a 2. So simply put, we are going to say our range is equal to the closed interval 0, 2. Closed because everything is included. These are curves. Everything is going to be included. So that's how we do it. But if you just want some form of a summary, you should just know that this 0 is representing the lowest value in y. This 2 is representing the highest value in y. So that's something you should realize. So our answer, the range is going to be 0, 2. Let us proceed to 6.3. Now for 6.3, we need to determine the amplitude. But before we get to the amplitude, we should appreciate that the amplitude is actually a fancy way of talking about a transformation. So there's a close relationship between an amplitude and the transformation. Look at it like this. We are looking for the amplitude of g. We are told that g of x equates to cos x plus 1. We have been taught when we looked at transformations of functions that this cos x part is actually the original function, and this one part is representing the transformation. But this transformation, as we have just learned, is also called the amplitude. So when we want to find out what the amplitude is going to be, it's simply a matter of quoting. Maybe that's why it has 1 mark. So the amplitude, it's simply going to be the factor which is added to cos x, that is 1. So 1 is the amplitude. That's how it's done. You have to remember the amplitude is the same as the transformation, and you should be able to tell the original function from a transformation. Now when it comes to 6.4, for 6.4, we are told that the function of x, right, is greater than or equal to g of x. So before we go anywhere, I want you to apply, or rather to appreciate something. What you ought to appreciate is this is actually a simultaneous situation. And I'm going to explain why I say that. Why am I calling it a simultaneous situation? It is because we are having two functions being equated. The function of x is equal to g of x. So naturally we have to be drawn to the points where g of x meets f of x, which is this point and that point. You understand? Because that question, even though it says greater than or equal to, but still there's an element of being equal to. So we have to notice that there's a simultaneous situation there because of the part of equating the function of x and g of x. Now after that realization, let us do the necessary substitutions a sin x is greater than or equal to cos x plus 1. And we already know that a is going to be equal to 1 because of the calculation we did. What it then means is we are going to replace a with 1, so simply sin x is greater than or equal to what? Cos x plus 1. Then when we transfer everything to the left hand side, sin x minus cos x minus 1 will then be greater than or equal to 0. As you can see, that then seals it off, showing us that that's a simultaneous situation. But we actually didn't have to do this. You might need to do this to prove to yourself that we have a simultaneous situation. Otherwise, if you didn't do that, you should actually quote the answer. The answer here is going to be x is equal to 90 degrees and x is also equal to 180 degrees. Why is this the answer? It is the answer because since we have seen that those two functions are simultaneously meeting at the point where x is 90 degrees and the point where x is 180 degrees, we are just going to quote those answers. That's why we said x is equal to 90 degrees and x is also equal to 180 degrees. So you simply, if you are equating functions and you are given the functions graphically, you simply find the points where those graphs are meeting, then you quote the x values of those points. That's why we said x is equal to 90 degrees and also x is equal to 180 degrees. So that will be 6.4 for us. Please don't hesitate to ask if need be. Then let us now attend to question 6.5, which now says, how about g of x minus f of x is equal to 2? So what is g of x? G of x is cos x plus 1. What about f of x? F of x, so we are just going to say subtracting sin x. The reason being a is 1. So it could have been written as a sin x is equal to 2 and boiled down to cos x plus 1 minus sin x, having replaced a with 1 is equal to 2. Now cos x minus sin x is going to be equal to 2 subtracting 1, which is 1, because this one goes to this side and becomes a negative. So we now have a situation where cos x minus sin x is equal to 1. In order for us to find the answer there are ways, there are actually two ways. One is an intuitive way. You are going to be looking for points where you have a factor 2. But I don't want to explain that because I think it's confusing. So what you rather do is you are going to test for all values of x. And it's a simple test. Don't worry, it doesn't take time. So testing for all values of x, you are going to test for 0, for 90, for 180, for 270, for 360. So it's simply going to be testing for 0, cos 0 minus sin 0. Is it equal to 1? If it is equal to 1, that means 0 is actually an answer. So using a calculator, if we say cos 0 plus sin 0, sorry, it's cos 0 minus sin 0. So on our calculator, we are saying cos 0 minus sin 0. We are getting 1. You see? So when we are now writing our answers, we are going to have x as 0. So let me write my answers in a different color. Therefore, x is equal to 0 degrees. But is it all? What about if we try with 90? So when we are trying with 90, it will be cos 90 minus sin 90. Does this give us 1? So where is cos? Cos 90 minus sine 90. This gives us minus 1. So this is not equal, meaning 90 is not going to be an answer. What about, so I'm just doing it here so that you can see what's happening, but of course your trial and error should be done properly on everything. So we now want to use here what? We have tested for 90, we now want to use 180. So cos 180 minus sine 180. So what is cos 180? Let's look for it. Cos 180 minus sine 180. It's minus 1 also. So it's not equal to 180 is not going to be an answer. Let us now look at 270. What is it going to be? Cos of 270 minus sine of 270. We get 1. So that's an answer. So when it is 270 degrees, it's actually going to be equal to 1. Which means on our answer, we are also going to have 270 degrees. And lastly, when we try 360, we want to see if it's equal to 1. So what is cos of 360 minus sine of 360? So cos of 360 minus sine of 360 is equal to 1. So yes, it's equal to 1. And because it is equal to 1, we have to put it here like this. So those are our 3 answers. Sine x is equal to 0 degrees, or 270 degrees, or 360 degrees. So what you do is you simplify this expression to the best of your ability, after which you are going to test for every value. When you keep up with the practice and keep on reading mathematics literature around this topic, you are going to see that there are easier ways of scouting and finding out which values are going to satisfy what you need. But for now, you have to stick to what I've shown you. Our last one is 6.6. The graph of f is reflected across the x-axis. Write down the equation of the new graph h. So what we have to know is that a reflection across the x-axis multiplies the function by -1. So what does this statement translate to? Reflection across the x-axis, which is across the x-axis, and this is the x-axis. It's going to do what? It's going to multiply the function by -1. This simply means h of x is equal to negative function of x. We are going to substitute the function of x part, so it's negative a sine of x. We know that a is 1. Therefore, we are going to say h of x is equal to minus sine x, and this would be the final answer. So I was rushing through this question, but I hope I was explaining sufficiently well. If you have any problems anywhere, please ask, and I'll try to explain slower. Thank you, and have a nice one.